A warm welcome to this platform. So we continue looking at organic chemistry. This is lesson 5. Lesson 1 covered the introduction, looking at the terms under organic chemistry, as well as alkanes. The second lesson, the focus was on alkenes. The third lesson, we looked at alcohols. Then the fourth lessons, we are just looking at carboxylic acids. In this one, we focus on esters. So to have an understanding on this part, make sure that you review or you look at lesson 1 to lesson 4 because everything is connected. So now, the question is, what are esters? So we can start. What are esters? So esters are just organic compounds. So esters are organic compounds that exist naturally. So are organic compounds that exist naturally. That is how you can define esters. Now, they exist naturally in what? In plants. So in plants, you can talk of the fruits, then and animals. So these are the ones that gives the characteristic smell of the fruits. For example, those are what you call esters. As you know, different fruits smell differently. You are able to tell that this is a fruit, this is a fruit, this is a fruit of this type. Then also in animals, in fats, okay? So they exist naturally in plants and the animals. But esters can be synthesized at laboratory level. Although they exist naturally, they can also be synthesized. So you can say esters can also be synthesized in the laboratory. Now, how can they be synthesized? By reacting alcohol and carboxylic acid. That is how they can be what? They can be made. Okay. So, what else do we need to know about this one? So the other thing that we need to know is the formation of esters. Since we are saying they are formed by reacting alcohol. So you can say alcohol plus or and carboxylic acids. What you're going to form is an ester and water. So that is what is formed. So when an acid reacts with a carboxylic acid, what is formed is water. I mean ester and water only. So here we want to look at the formation of an ester. So we are going to react. I say, for example, let's say we have the simplest alcohol, which is methanol. Now, the structure for methanol, this is the first alcohol in the series. So the structure is this one. I mean, the molecular formula is that one. Then for carboxylic acid, we look at methanoic acid. Methanoic acid, the structure, this is the first one in the series as well. It has 0 carbon. As you know, acids start from number 0, 1, 2, and so on and so forth. So now what is going to form here is an ester. But to write the molecular formula of an ester, let me give it in terms of a structure first. You see how the reactions occurs. So you have OH this side, then of course hydrogen, 3 of them, like this. So this is how it appears in terms of structure. Now this one is reacting with the acid. Let me put the functional group first. So I'll put the functional group first, which means this part first is the one that I will draw so that they are facing each other like this. This is the functional group. Then this hydrogen, I will turn it the other side. Okay? In other words, I've started with COOH. Okay? This part. All right. Now, how is it, or how is the reaction, or how does the reaction occur? So a catalyst in this one What is the name of the catalyst that is used in this one? That is another question that you should know. What is the catalyst that is used in this case? So what is used here is concentrated sulfuric acid as a catalyst. So the conditions are very important to understand. So concentrated sulfuric acid is used as a catalyst. Now, how does a reaction occur for it to form an ester? So one thing you should know that the acid part give the OH, then this one, the H. So this is going to be eliminated as the what? But I'm not saying you do that when writing, just showing you that. So when this is eliminated, so what are you going to remain with? You're going to remain with this part attached to a carbon. So in other words, the ester is going to be C like this. Then of course O, otherwise attached to a carbon, like this. So this is an ester. This is an ester that is going to form. Now, plus water, please, or ester and water. What is the name of the ester? So we come back to the naming. So this is called methanol, as we know. This is called methanoic acid. Okay. Now, where we are coming from, or let me just not go there. This that you are seeing as the ester, the first part comes from the alcohol. So you remove the whole of this part of the alcohol, then you add YL. So this code is going to be methyl. Then now for alcohol, you remove the whole of this one. No, not the whole of this one. The whole of this one. Then you add this one. Okay? No, it's supposed to be O-A-T, if I'm not mistaken. So which means this one is going to be methanoate. Methanoate. Now that you have two parts, you can join them, and that is the name of an ester. So the name of an ester is going to be methyl methanoate. So that is how you name it. So the first part comes from the alcohol, where you just remove this and add YL. Then for the acid, forget about the acid, just methanoic here becomes methanoate. Then the name is methyl methanoate. I guess that's no problem. I guess there's no problem there. Let's look at the second one, or the second example. What about if you have, so I'll say example 2. What about if you have ethanol react with ethanoic acid? What are you going to have? So look at this. It occurs in the presence or a catalyst sulfuric acid, concentrated sulfuric acid. So now the structure of ethanol, you know, the molecular formula is this one. And I guess you're not surprised where these numbers are coming from. Then for ethanoic acid, how is ethanoic acid written? Otherwise, ethanoic acid is the one that has one carbon. Okay, the general molecular formula of acids, you know that is this one. Then COOH. So which means we are going to have a 3, then like this. What is going to form there? So in terms of structure, this one has 2 carbons. But of course, at the end, there should be OH, as you know. So this is ethanol. Then ethanoic acid, I'll start with this part. So here react with. Then how many carbons? 1 and 3 hydrogens. Okay. So now we have this methanoic acid reacting with this one. What did we say? The acid contribute OH, then the alcohol just H. So water is eliminated here. So we are going to have this whole structure, which is 2 carbons joined to O, then of course to a carbon like that. Then there, how many hydrogens do we have? Like this. Okay, that will be the structure. Now, what is the name of this structure? So the first part is ethanol. So like we said, ethanol become ethyl, then ethanoic acid become ethanoate. So the name is going to be ethyl ethanoate. So that is the ester that is going to form. Now, in terms of the molecular formula, how is it going to appear? Look at this. So for the molecular formula, you can write this in advance in the middle, which is this part. Okay? Which is that part. So this part is written as COO. Okay? Now you join these other parts now. So this is the center part. If you want to write the name. So I can put, the molecular formula. I can put COO. Then what is behind it? We have a carbon, hydrogen 2. Okay? Then we have another one, hydrogen 3. So in other words, you can even get this one. How many carbons? So carbons, there are 2. How many hydrogens? 1, 2, 3, 4, 5, which is the H5, like this. Okay? So that is how you can write it. Now, ahead of it, we have 1 carbon and how many hydrogens? 3. So, like this. So this is the molecular formula of this. Any problem here? I guess there's no problem writing ethyl ethanoate. Okay. Let us have one more. Let me say this time around, you have, let me use which one? Ethanol react with propanoic acid. What is going to form? Now, ethanol, the structure is, it has 2 carbon, please. So this is the structure of ethanol. So these are very important when it comes to writing the structure for the ester. Then ethanoic acid, propanoic acid has 2 carbons. So from the general formula, 2N plus 1. So has 2 carbons, which means you put a 2 there, it's going to be a 2. Then 2 multiplied by 2 plus 1 to be H5. Then of course CH. So what is it going to form? So now let us look at it. I should have put this one in terms of structure as well. So 2 carbons. And let me start with this. Okay. So the structure for this one is C, or I should have written CH5, COOH. Then this one also I put it in terms of CH5OH. So now when this react, what is it going to form? What is it going to form? So when this react, that is the ethanol and propanoic acid, when they react, what are they going to form? So in terms of structure, it will appear like this. So these are hydrogen around. Then this one react with, I'll start with this. So this is going to be like this. Then how many carbons? Hydrogen. So this is how it appears. That is propanoic acid. This part goes this. So water is eliminated. What is going to form? This is ethyl. This is propanoate. By now we know. So the name is going to be ethyl propanoate. The first name comes from the alcohol. The second name from the acid. So we are going to have this structure. So the first part here, 2 carbons. Let me just put it nicely. So just take a small arrow here and we say carbon, carbon for the first one here. That. Then O connected to what? Connected to a carbon. Then how many carbons afterward? 2 carbons. So please put the hydrogens around. So hydrogen there, hydrogen there, hydrogen there, and also the end part hydrogen. So this is going to be the structure. Now, what about the molecular formula? So I said easy to start with this. So you write COO. Then now behind it, what is there? 2 carbon, 5 hydrogens. So C2H5. Then ahead of it, 2 carbons, 5 hydrogen as well. So it's going to be, so this is the molecular formula, otherwise known as ethyl propanoate. Is there any problem up to this point? So what is important here is be able to write the molecular formula of the structure that you are given, and also be able to draw the structure formula. Also be able to write the reaction, this presenting it in this form, showing what is eliminated. So please, there's water at the end there. That is what is important here, and also be able to name. And when you are given the name, you should be able to tell what were the reactant. For example, if you are given ethyl butanoate, for me, I know that the first part, the alcohol was ethanol, and the second part, the acid was butanoic acid. I think it's as easy as that. So the first part comes from the alcohol, the second part comes from the acid. I guess we have no problem up to this point. Now, let us have a look at the chemical properties of esters. What are the chemical properties? So, chemical properties of esters. What are the chemical properties? 1, they undergo hydrolysis. They undergo hydrolysis. They undergo hydrolysis. Okay, so hydrolysis is just the addition of, okay, so hydrolysis, you add water, which means you are breaking them. We are breaking the ester. So when you break down the ester, you know that water is lost when forming ester. So when you add water, in other words, hydrolysis results into formation of the acid and the alcohol. You are just breaking the molecules that reacted. So now hydrolysis, this process can also be used in making of soap. So hydrolysis to make soap, and this is when it occurs in the presence of a base. So hydrolysis simply adding water to break the ester into its individual component. But when it is done in presence of the base, It is called saponification, the process that is used to make soap. So that is about hydrolysis. Then the other one, esters also undergo combustion. Esters undergo combustion. Now, in the full supply of oxygen, what is formed, is carbon dioxide and water. So esters undergo combustion. So have a look at some more chemical properties of these esters. But we can end by looking at the uses of esters. What are the uses of esters? One, esters are used to make artificial flavors. So we can say used to make artificial flavors such as spice and all that. So they are used to make artificial flavors and of course other essences that are used in the food. Aside from that, they're used in making of perfumes. So used in making of perfume. So the question, sometimes you find the question such as, let's say you are given the list of the compounds, then they ask you which one is used in the making of perfume. So you should be able to tell that this is an ester, and you know the structure of an ester. You should be able to identify this is an ester, and of course this one is the one that is used. Aside from that, they are used in making of plastics, used in making of plastics. What is the other one? They are used in making of soap and detergents. So, used in making of soap and detergents. What are some of the uses? So, be able to list them in the comment section. List as many as you can. Otherwise, there are a lot of uses that we can look at. So, this brings us to the end of the part esters. The next part that we're looking at, we'll start looking at macromolecules, where we are going to discuss polymers, that is synthetic and natural polymers. Under synthetic polymers, we'll get to look at polymerization, that is synthetic polymerization, that is additional polymerization. Then examples here, we'll look at nylon and terylene. Then, of course, under natural, we'll look at proteins, carbohydrates, and fats, and we'll get to relate the natural and the synthetic. We should be done with the topic. Thank you very much for staying up to this point. So please, if you are interested to join us for online lessons, you can just get in touch on the number 09762563. If you are interested to come for physical lessons, we are found in Kabwata, just near Kabwata Primary School. So if you stay in that area, you can get in touch, and of course we can give you direction. Otherwise, see you in the next one.